Okay, this is the challenge example at the end of chapter 7. Each chapter, or I should say most chapters, have a challenge problem at the end, and what this does is it uses pretty much everything in the chapter: the massless string approximation, friction, free body diagrams for two bodies that are connected. So the scenario is, and you can see from this picture here, is there is a safe that's being in the process of being stolen. That's S, and there is a large mass of furniture that's put together here to slow the descent of the safe to the bed of the truck. There is a 3-meter drop that the space has to undergo to get to the bed of the truck, and there's a 0.5 coefficient of kinetic friction between this large furniture mass and the floor. And so the question is, what's the acceleration with which the safe hits the bed of the truck after dropping this 3 meters? So we'd like to know that, and what we do then is we do two free body diagrams, one for the furniture, that's this left one, and one for the safe, that's this right one. So starting with the furniture, there is the weight of the furniture downwards and the normal force of the floor pushing up, a tension force of the string to the right, and a frictional force to the left. And the furniture is accelerating to the right with some acceleration A. Then we can write a Newton number 2 in the x direction for the furniture. The mass of the furniture times the acceleration to the right is equal to the rightward tension force minus the frictional mass. And so we can, from the y Newton number 2 for the furniture, we can see that n is equal to the weight of the furniture, and therefore we can replace F sub k with mu sub k times mfg. So that's the equation for equation number 1, which is going to be the Newton number 2 for the furniture, which I think I wrote twice, so my apologies for that. Then we can write a Newton number 2 in the y direction. There are no x forces acting on the safe for the safe, and since the acceleration is down, similar to the Atwood machine problem, we're going to write the Newton number 2 as ms times minus a is equal to t minus msg. This is the weight acting downward, and so we can multiply through by minus 1 and get MSA equal to MSG minus T. So if we take these two equations and we add them together, again, a lot of similarities with the Atwood problem. We get the sum of the masses times the acceleration is equal to MSG, that's the weight of the safe, minus mu sub k times MFG. This is the frictional force. So we can solve this for A, and it is going to be m sub s minus mu sub k m sub f divided by the sum of the masses times g. And so if we plug the values in, the furniture is 1,000 kilograms and the safe is 500. 500, I'm sorry, I got it backwards. The safe is 1,000 kilograms and the furniture is 500 kilograms. So that's gonna give us in the numerator 750 kilograms divided by the sum of the weights is 1,500 kilograms times g. 750 divided by 1,500 is 1/2 g. And that's going to be an acceleration which is to the right for the furniture and vertically down for the safe. So now we can use kinematic equation number 3 to figure out if it's dropped a known delta y with a known a sub y, the safe that is, what the final velocity is. And so with the initial velocity for the safe is 0, so we can solve for Vy, take the minus sign because it is going to be a minus velocity downward, and so it's minus 2 times minus 1/2 g. So this is the magnitude for A, but since it's a downward A, I'm going to bookkeep a minus sign here, and also because delta y is downward displacement, I'm going to bookkeep a minus sign for the 3 meters. And so if we figure that out, that's minus 5.4 meters per second. That's going to be the velocity with which the safe hits the bed of the truck. And again, I'm using g equals 9.8. And so this is a rather large velocity for a 1,000 kilogram safe to hit the bed of a truck. And so my question to you is, if we keep everything the same in this problem, but m sub f, what should m sub f be so that v sub y for the safe just before it hits the bed of the truck is a 1/4 of a meter per second instead of this rather large minus 5.4.